Okay, so there's been a lot of talk, I guess, on the property graph side in this workshop, and so I'm going to talk more, maybe a little bit on the RDF side. That's the title of my talk, but of course we could flip this around and look at it the other way, and that's kind of like a preview of coming things, sort of where I'm going to go with this talk. So. Who am I? So I'm in the Amazon Neptune team, but I've been doing a lot of W3C stuff, specifically the semantic web stack. I participated in many of those activities. Anyway, here's sort of my game plan. I want to talk a little bit about knowledge graphs, interoperability, and the semantic web stack of specifications. And then I'll talk about this kind of crucial question of sort of RDF versus LPG, or is it RDF and LPG? And I'll give a little bit of preview of this project that we have running that we call OneGraph. So some of you have seen this picture. I've used this before. I just wanted to put it here because I find it kind of fascinating that I talk to a lot of customers and they say things like, oh, these new technologies. And I'm like, well, maybe not so new. So Leonard Euler published his first work on graph theory in, I think, 1734, which incidentally was the same year that Carl Linnaeus published his work on the taxonomical classification of plants and animals, and I think he also classified rocks or something like that. Now we on the graph side, we fast forward. Of course, graphs are the essential underpinning of computer science in many ways, and in the 1960s, the social scientists discover graphs, and we get the small world experiment, the Adair's numbers, and whatnot. And then again, fast forward in 1997, the sort of the work on ontologies and work on graphs comes together in this what we now refer to the semantic web. And the semantic web technologies, regardless of what you've heard a lot of people say about them, are sort of the essential technology for modern knowledge graphs. Okay, so that's kind of like my take on, or my view of where we are, and so a lot of talk about standards in this workshop. So I hear this talk about standards, and I'm thinking, well, RDF really was the first graph standard, and we've had that now for almost 25 years, and Sparkle was the first standard for a graph query language, even though the first version of Sparkle was kind of like a unmitigated disaster in some sense. But the current one is a lot better. So the interesting thing, particularly in the sort of context of the previous talk about the schema graphs and things like that. So we've had schema graphs in RDFs since the very beginning. And RDF is kind of on the data side the equivalent of a homoiconic programming language, in the sense that definitions in RDF are also data. So this kind of means that in an RDF, if you interchange RDF data, you can actually communicate the schema, the definition of the data, as part of that data that you're handing over. And it was a sort of a key design requirement originally for RDF, and I still think of it as sort of a key aspect of being able to use RDF for actually interoperating with other systems, other organizations, and being able to interchange data. Now, if we think about knowledge graphs, they're often sort of seen as one way kind of out of the silos for data. And that's a very nice thought. We don't like silos. We want to get the data out of them. knowledge graph sort of ostensibly could provide a solution for that. But lately, when I've been looking at things, I see this. So old silos, of course, were these kind of things where a single application controls some set of data, and if you're really lucky, there's some actual API. Of course, it's a custom API for that particular application that lets you get to that data. And lately, and last year, I participated in this NSF knowledge graph activity, and I saw this thing where people are talking about building sort of single-purpose knowledge graphs, and no interoperability, no interlinking, and I'm thinking those are the new silos. So interoperability on many different levels seems to be one of those things that, first of all, people don't necessarily always understand, and that's something that's direly needed. So given the kind of the new silos, I'm thinking we're still here. So the Tower of Babel, everybody's talking, nobody's understanding. Every new data set is a new language, effectively, with its own vocabulary and all the horrors that go with that. So the question really is, what does it actually mean to have interoperability? So of course, what we've had, common format. Now you can standardized common format, I should say, enables you to exchange information with others. Common query language now enables some type of interworking and also frees users from vendor lock-in. So ostensibly, you could switch your backend if it uses the same query language, and in many cases this actually works. But I think that we also need a sort of way to share semantics of the data, because otherwise we end up with this situation where, well, we can exchange the data, but at the other end you have to sort of re-articulate the semantics, and I sort of view that as a kind of form of technical debt. Why would we do that if we could actually communicate the semantics in an interoperable way? And then kind of related to that, is this that we have to have a mechanism of sort of clearly identifying things, giving things identifiers that can also be communicated. I'm usually sort of an easygoing person, but I'm highly sort of intolerant when it comes to technologies that I see as sort of reinforcing the old mindset of silos. So now, of course, all this is about graphs. So a graph is a graph, right? You know, what's the big deal? What I find when I look at, for example, our customers, Neptune customers, is that when they're building knowledge graphs, gravitating towards the semantic web technologies is a good idea. But there are other graph applications which often are closed systems, and then the graph is really just a very large, complex data structure. And there's nothing wrong with that. Since the dawn of software engineering, that's what we've been doing. We write code that manipulates data structures, and that's perfectly fine. But there is this rift between the two, because on the one hand, we kind of treat the graph as a sort of a logical representation of something else. We build a representation of the world, and we're modeling the world. Whereas on this other side, it's sort of more of a data structure in a closed system. And I think that this question, which I refer to as the rift, is sort of, should I use RDF or should I use property graphs, is harmful to the entire graph community. With Neptune, we sort of chose to support both these. We wanted to give customers the choice that if they want RDF, they can have RDF. If they want label property graphs, that's also fine. But the sort of the law of unintended consequences hits us here, and it turns out that the customers have to choose. It's not just that they have the choice, they actually have to exercise that choice. And not only does it cause confusion, newbie customers who don't know much about graphs, they come to me and says, hey, which one should I choose? I have no idea what to choose. Sometimes they choose wrong. And then walking back that decision someday may not be so easy. Now, when you do choose, then it limits kind of what you can do. So most importantly, with Neptune, it limits the query languages that are available to you. We support Gremlin and OpenCipher on the property graph side and Sparkle on the RDF side. No big surprise there. Both graph models have their pros and cons, but these pros and cons are not the same. There's different good things about RDF than there are about property graphs. So what are those good things about this? So rather than saying what's good and what's bad, I decided I'm going to list what's good and what's missing. So RDF has a clearly defined, sort of predictable semantics for graph merging. It has strong global identifiers. It has a schema language. RDF data is self-describing. We have standardized interchange formats, so I can hand my data to somebody else, and they can get the same graph out of that what I had. RDF has a model theory that allows reasoning to be built for RDF graphs, and RDF, and of course this comes from Sparkle. We can use federated queries in a standardized manner. So those are all, I think, good features. But there are things missing from RDF. So the design of RDF, and I know this because I participated in the original process, is very, very deliberate. RDF is the way it is for a reason. But it's deliberate from the knowledge representation standpoint, not so much from the programming standpoint. And so sometimes programming with RDF is kind of a horrible experience. And one reason why it's horrible is that I think we really messed up composite data types. In RDF, composite data types are constructed using the graph structure itself, which means that it's like ridiculously hard to actually program those. And also, and this is a sort of a funny anecdote, but not really. When the original data access working group at W3C was drafting the first version of Sparkle, I told them that they should really make sure that the query language can handle paths. At the time, I was writing my PhD dissertation, which was about path queries. So paths were kind of on my mind all the time. And this is what they said, and I'll quote them verbatim. So the response I got was that we're not going to do it because paths are not a use case for graphs. I kid you not. It seems kind of funny, but of course it's a disaster. And my reaction was, well, you guys, you're idiots. And now, of course, we see that we now have Sparkle 1.1 that has the property path mechanism, which is an improvement. It's not quite there because we cannot do path discovery with Sparkle. You can write a query that traverses a graph, but afterwards, it's impossible to find out exactly what path you took. I'm sorry?
In the interface of RDF, normally do you not think about it? Do you think about logical?
Well, it's not true. I understand what you're saying, but it's I was there. We did think about the graph. Yeah. So, but you're partially correct. There were a lot of people who, coming from a very strong logic-based formal knowledge representation background, just saw kind of RDF as syntax for sort of a simple system of logic. This is true. And other things that are missing from the RDF side are there's no way to do recursive queries, and there's no the query language is not composable. Okay, so this is RDF. So what's the situation for labeled property graphs? And I'll show you, because I can just edit this a little bit. I think this is what we have for property graphs. The things that are good about RDF are more or less all missing from property graphs. But on the other side, the things that are missing from RDF that I really want, they're the really good features of property graphs. In a way, sort of once I understood this, and I've been doing this for a long time, but I was really surprised that it's really so complementary. So, what if we could actually have everything, all the good stuff? So, and for this reason, we have conceived this project OneGraph. Some of you may realize this is a Tolkien reference. Brad actually thought it was too arrogant to name it like this. OneGraph to rule them all, right? So we'd like to use the good features of RDF Sparkle on the LPG side, and then vice versa. Also, no more complaints that RDF doesn't have edge properties. And now we have this RDF star working group, which in a way sort of is also fixing this, and that moves RDF closer to property graphs. Not predictably, not quite, but we're getting closer. We could mitigate the lack of path discovery in Sparkle. We could wait 4 years for W3C to get their act together, or what I really want to do, I want to run Gremlin over RDF, and I suppose soon I could also run GQL over RDF. We could have ontologies for property graphs. We could have reasoning. But the real goal here is the graph interoperability, so that people can build knowledge graphs that are open and can be interlinked, can be exchanged, even if they're using property graph technologies, if that's what they want. And I'm hoping it will also mitigate the confusion that our customers have. So the OneGraph is really sort of a meta model that kind of unifies these RDF star, and LPG meta models, and each of these is sort of a view of the 1G data that is kind of potentially missing some things. So this means that when we do round trips, we could have, you start from RDF, you go to OneGraph and come back. That's a lossless round trip. But there are some 1G graphs that if you go to RDF and come back, you may have lost something. So this is inevitable. And now there are a lot of technical and definitional hurdles for us to accomplish this. The practical challenge, I suppose, is that these two graph models are used differently. But if you want to sort of have a better understanding what the technical challenges are, we have a paper in the Semantic Web Journal, which is sort of a gallery of challenges. It doesn't really have the final answer yet, but we're very, very, very close to having an actual sort of publishable formal definition of OneGraph, which we will do. We don't think that we should keep this to ourselves. So, given this, the end goal should be this. So we have the good features of RDF, and we have the good features of property graphs, and we can have all of those. At least in my dreams, we can have all of these, and I think we are well on our way to getting there. It's work in progress at the moment. Thank you. Are there any questions? One will speak at once.
Yeah, what prevents us from having named queries in any graph language? What prevents us from introducing named queries in any graph query language? and have recursive queries, for example.
Recursive queries?
You can probably extend Sparkle with named.
Yes, of course. We could extend, but in order to make that standardized query language, it will take minimum 4 years of W3C to do that.
Okay.
And I want to do that sooner than that. I'm going to retire soon. And I don't want to wait that long. Okay? So I really want Gremlin over RDF. Seriously.
Yeah, I see what you're talking about. Yeah, it's pragmatics.
And I like the idea of structured queries as path traversal. I mean, I'm a big fan of Gremlin. I want Gremlin over RDF.
Okay, I have a stupid, naive question.
There's only inappropriate answers, no stupid questions.
Okay, so it used to be everywhere I went, I heard about Sparkle RDF. And for the last 8 years, I never hear Sparkle RDF. So has it truly, as I've observed, just dropped off and only those at Neptune?
No.
I mean,
no, absolutely not. So let me give you some examples of current RDF usage. So in the common crawl dataset, which is 3 billion pages or documents from the web, almost exactly half of them contain some RDF. Every Adobe document contains a small RDF graph. Per my observation, the things that come out of my camera and go through the Adobe toolchain have a graph of a little more than 100 edges, each photograph. So there's a lot of RDF out there. But the way I sort of look at it is that, if I think about the Gartner hype cycle, so you have the peak of overbloated expectations, and then you go down and you get to the trough of disillusionment, and then you go, what is that last thing? It's the plateau of maturity or something like that. I think that's where we are with RDF. Thank you.
Thank you.
Oh,